That PDF full of tables you need in Excel. A bank statement, an invoice, a report someone exported to PDF and now the numbers are trapped. Copy and paste turns the whole thing into mush, and retyping it by hand is a nightmare. Here is the good news, a pure Python library called pdfplumber gets that data into pandas in about 10 lines of code, the text, the tables, even the exact coordinates of every word on the page. No Java, no Ghostscript, no external tools to install, just pip install and go. In this walkthrough we will open a PDF, pull its raw text, extract real tables into a pandas data frame, handle the tricky layouts where the auto-detection struggles, grab word-level bounding boxes when you need precise positioning, and finally see how pdfplumber compares to Camelot, Tabula, and PyPdf too, so you know when to reach for which. By the end you will be able to take almost any table-heavy PDF and turn it into clean, structured data you can actually work with. Let us get into it. First, installation, and this is where pdfplumber already wins. It is pure Python, so there is nothing else to set up, no Java runtime like Tabula needs, no Ghostscript like Camelot wants. One command, pip install pdfplumber. That pulls in pdfplumber and its dependencies, including pdfminer.6, which does the low-level PDF parsing underneath. You will almost always want pandas alongside it, so install that too with pip install pandas, that is what we will load the extracted tables into. Once both are installed, you bring them into your script with import pdfplumber and import pandas as PD. That is the entire setup. No system packages, no path juggling, no wrestling with a Java version. If you can run pip, you can run pdfplumber, on Windows, Mac, or Linux, the same way every time. With those two imports in place, we are ready to open an actual PDF and start pulling data out of it. Let us open a PDF and read it. pdfplumber gives you a context manager, so you write, with pdfplumber.open, then your file name in quotes, as PDF. Using with is the right way, it makes sure the file is properly closed when you are done. Inside that block, the PDF object has a pages attribute. pdf.pages is just a list of page objects, one per page in the document. So to grab the first page you write page equals pdf.pages, index 0. Now, from that page, the simplest thing you can pull is the raw text. Call page.extract text, with empty parentheses, and it returns the entire text of that page as one string, laid out roughly the way it appears, or it returns none if the page has no extractable text, which happens with scanned image-only PDFs. You can print that string, search it, or run a regular expression over it. To walk every page, you just loop, for page in pdf.pages, then call extract text on each one. That is the core rhythm of pdfplumber, open the file, reach into pages, and call an extract method. Text is the warm-up, next we go after the tables. Now the main event, pulling tables into pandas. Every page object has two methods for this. Page.extract tables, plural, with empty parentheses, returns a list of every table it finds on that page. Page.extract table, singular, returns just the single largest table it detects, or none if it finds none, use that when you know the page has exactly one table. The shape of the result is the key thing to understand. A table is a list of rows, each row is a list of cell strings, and an empty cell comes back as none rather than a blank string. So a 3-column table gives you a list of lists, and the very first inner list is usually your header row. That structure drops straight into pandas. You write, table equals page.extract table, then df equals pd.dataframe, and you pass table, index 1 onward, as the data, with column set to table, index 0. In plain terms, use the first row as your column headers, and everything after it as the rows of the data frame. That one line turns the raw grid into a real, labeled data frame, and from there you have all of pandas, filter it, clean the columns, convert types, and write it out with df.to_CSV or df.to_Excel. That is the whole path from a locked-up PDF table to a spreadsheet you can use. Real-world PDFs are not always clean, and sometimes the automatic table finder gets it wrong, it misses a column, or merges two together, or finds nothing at all. The reason is that pdfplumber detects tables by looking for lines, and not every table is drawn with lines. So it gives you control through a table_settings dictionary you pass into extract tables. The two settings you will reach for most are vertical_strategy and horizontal_strategy, and each takes one of three values: lines, text, or explicit. The default is lines, which means find the actual drawn rulings on the page. If your table has no borders, the columns are only separated by whitespace, switch the strategy to text, which infers the column and row boundaries from the alignment of the words themselves. So for a borderless table you would pass table settings equals a dict with vertical strategy set to text and horizontal strategy set to text. And when a table has, say, horizontal lines but no vertical ones, you mix them, horizontal strategy lines, vertical strategy text. When you are not sure why extraction is off, pdfplumber has a debugging helper, page.debug_table_finder, which lets you visualize exactly what lines and cells it thinks are there so you can tune the settings until the grid matches reality. A quick note on merged cells: pdfplumber returns the raw grid, so a value that spans several cells typically lands in one cell with the rest coming back as none. You handle that in pandas afterward by filling those values forward. The takeaway: if auto-detection fails, do not give up, switch strategies from lines to text and it usually clicks into place. Sometimes a table is not really a table, the data is positioned by coordinates, not drawn in a grid, and you need to know exactly where things sit on the page. pdfplumber exposes that too. Call page.extractWords, with empty parentheses, and you get back a list of dictionaries, one per word, each with keys like text, x0, x1, top, and bottom. x0 and x1 are the left and right edges of the word, top and bottom are its vertical position. Here is the one thing that trips people up about coordinates: pdfplumber measures from the top left of the page, with the top value increasing as you move down. That is the opposite of PDF's native bottom left origin, and it is much more intuitive. You also get page.width and page.height to know the size of the page, and page.chars for per character data if you need to go even finer than words. Once you know a region's coordinates, you can zero in on it. Page.crop, passing a bounding box tuple of x0, top, x1, bottom, returns just that rectangular slice of the page, and page.within_box does the same thing, restrict everything to a box. Then you can call extract text or extract table on that cropped region alone. That is how you pull one column, one corner, or one repeating block out of a messy layout with surgical precision, instead of grabbing the whole page and cleaning it up later. So where does pdfplumber fit among the alternatives, and when should you pick something else? pdfplumber is pure Python with no external dependencies, and it is the best all-rounder when you need text, tables, and coordinates together, with fine-grained control over how tables are found. Camelot is excellent specifically for tables that are drawn with clear ruling lines. Its lattice mode is very strong there, but it needs Ghostscript installed and it is really only about tables, nothing else. Tabula, through the tabula-py wrapper, is a mature table extractor, but it wraps a Java program, so you need a Java runtime on the machine, which is a real deployment cost. PyPdf2, now continued as PyPDF, is great for manipulating PDFs, merging, splitting, rotating, pulling text, but it is weak at structured tables. It is the wrong tool if a clean grid is what you are after. And PyMuPDF, imported as fits, is extremely fast and has gained solid table extraction of its own, so it is worth knowing if raw speed on huge documents matters. The short version: reach for pdfplumber first for mixed text and table work and anything needing coordinates, consider Camelot or PyMuPDF when a table is heavily ruled or when you need maximum speed. Use PyPdf for page-level manipulation rather than data extraction. Let us put the whole workflow in one frame. Install with pip install pdfplumber, then import pdfplumber and import pandas as PD. Open a file with the context manager, with pdfplumber.open, file name, as PDF, and reach a page through pdf.pages, index 0. Pull raw text with page.extract text. Pull tables with page.extract tables for all of them, or page.extract table for the main one, then feed it into pandas with pd.DataFrame of table, index 1 onward, columns table index 0. When detection struggles, pass table settings with vertical and horizontal strategy set to lines, text, or explicit, and use debug table finder to see what pdfplumber is finding. When you need positions, page.extract words gives you every word with x0, x1, top, and bottom, remembering the origin is top left, and page.crop or within box zooms into a region. That is genuinely the whole library for table work. If you want to sharpen your everyday Python along the way, I have a free guide to the Python interview questions that come up most, linked in the description. Great practice whether or not you are job hunting. And if you want to level up faster, there is the Python Power Pack, 50 real-world snippets, idioms, and interview prep, for $19, also linked below. Subscribe for more practical Python, and next time a PDF tries to lock up your data, you will know exactly how to get it out.